Oh, that's coming out so smooth. I was getting a little burr here, and I kept trying to go a little bit slower, and it just left a bigger burr. So I went from .008 feed FP or IPR to 9, and no more burr. What I did, there's so much of a difference in diameter here. Brad at Tactical Keychains kind of pointed me in the right direction with I was trying to do CSS, constant surface speed, so it would automatically adjust, and IPR. Okay, and the IPR, that measurement kept changing because it would speed up so much or slow down so much as the diameter got bigger, just from pulling the tool away. Okay, and then when it came in, it would have to raise it back up, and and then it wouldn't set the IPR back to where I wanted it. So I've been cutting them at .008 inch per revolution, which is half of the nose radius on both of these tools. RPMs, what I did was I went through for every cut, basically, and figured out the RPM for 780 surface feet per minute. Okay, I went all the way from 600 to 1200, and 780 when I got everything dialed in and finally got it to where I wasn't getting any chatter, which I started picking back up. I'm going to assume it's that bad, the insert getting dull there. Anyway, 780 seemed to be the target range. Okay, and I was trying to do 3-4 cuts at a time and set it, and then I figured, well, if the surface feet per minute dropped off a little bit, no big deal. I didn't like it, so I basically went in, and so if the audio's up enough, when I blow the air, it kills the audio really bad. So I usually have to turn the volume way down. But it will. I've got like a half a second pause for it to do the RPM, to up the RPM, and it's really not needed. It seems to be doing it pretty well. But it'll change every time, and so when it does the first few cuts, they're definitely thinner, and you'll see the chips are a lot lighter. But then it starts cranking out some pretty heavy chips, and I was putting out some way heavier ones, but it was stalling the spindle. Trying to do a 25,000th depth of cut. I kept thinking maybe it was slipping or something like that. It literally just stalled the spindle. The servos kept going. I've got some other pictures of that where it just cut, just shoved a cutter right through the metal. But anyway, let's fire it up. We'll get some good footage of this. I've got some other footage, stuff like that, but I've got the one that's chucked up in 2 more slugs. And it's pretty sad because out of like 100 slugs, I've got 2, 4, 6, 8, 10, 12, 14 good ones. I got about 10 others that might work. I got to clean them up. I got to tweak the dimensions a little bit, do a little, little sandpaper, a little emery to it kind of thing. So this is a fairly expensive, because that way more than doubled or tripled my cost. But I got to do them in-house. So I still have to do the backside. But with all the mistakes I've made out there, got a whole pile of them. I shouldn't have to touch any of the good ones to get the backside dialed in. And now that I know the surface feet and the tool nose radius, blah, 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 all that kind of stuff, it should be a whole lot easier to dial that in. So we'll see. So this is a machinable arbor, and I bought it years ago and machined it when I was making these manually on the lathe, because my big lathe was not conducive. I didn't have any small jaws that would fit inside, kind of thing, and so I machined it so that I could put, once I did the inner bore, I could put it on there, and then I could do basically the whole outside. And I was having a bit of trouble trying to get I can't open it up wide enough for the 3-jaw to grab, and if I grab the inside, because of how it is right at the inside of the jaw, they have a little groove in there. Well, it falls into that groove, and I couldn't get it to stay very concentric. So once I put it on here, it stays very concentric. And there's the 3/4 inch shank on this, and I've just got it right up into the TTS 3/4 inch collet. Okay. Now, since if I'd had another one of these, I could have machined it. I could have put a step in it to stop it. I need it to stop because I'm cutting the inside bore here now. So what I came up with was this is the inner race. This is the inner race. I just cut the cage off and took all the rollers off. But that's what this is made for, is to fit that bearing race. So then I got 2 other pieces, and they're actually machined fairly flat. They're doing pretty good. So and there's an Allen bolt in the bottom here. I'll just show you real quick. That has a taper on it. Okay. See that taper? So that taper expands the arbor. In fact, you expand. It's kind of a trick when you machine them, and they do come with instructions. You need to machine them with it expanded or whatever kind of thing. I don't remember right offhand. But it's been working really nice.